Hello, welcome. Uh, Good day. So today we are presenting DC-MHS. It's an Experience Center Expo demonstration that we have. So basically, we're going to talk about the driving the DC-SCM innovations and interoperability. And I have Intel as well as Axiado after me. So this whole presentation is actually 3 topics. So my name is Munir Ahmad, and Lawrence and Raghu as well. So what I'm trying to cover is the DC-SCM focus demo that you can see on the next one, which is basically Intel and Lattice work together to do this LTPI interoperability demo, and why it is important, why this is so challenging. That's what my topic is, and we do have actually demo showing on that side. So if I want to go, let me skip to this one. So if you look at what is the DC-MHS doing, so in a big part, DC-MHS is giving the capability for the companies to basically segregate this, bigger components in the server, right? You don't need to have spun off your server every time there's a new CPU come on. So basically, all the major components is separated. And the DC-SCM is actually a subsection of that, right? So DC-SCM, what DC-SCM did is separate the security and control module from the monolithic server, so you have independent flexibility that you can develop, so you don't have to stick to the HPM development, and all the components on the DC-MHS is like that. But if you look at the DC-SCM, what the DC-SCM introduced is a new spec called LTPI, which is the totally new thing. And to an OCP-inspired event, you want to have the fully interoperability of the DC-SCM, right? And that's the whole topics here. And this interoperability is so important because in order to make the OCP-inspired plug-and-play devices, you want to make sure that your LTPI is working with multiple vendors, right? Right now, there is 2 major vendors on LTPI. One is definitely Intel, another one is Lattice. And you want to make sure that the interoperator works properly, right? So there's 2 major things to this I like to highlight, and I like to thank you, Intel, for that. Because as you know, so any spec development, it's one thing is spec development is one. One thing is making within a reference design within your own board is one thing, but it's much more challenging when you talk about that your device is working with somebody else's device running a newly developed spec, right? Because anytime you have first generation of this spec, not everything is very well tweaked. There is things that you're going to find out when you're going to start trying to do this, maxing together 2 components, right? So that's definitely challenging. And the second challenge is, I would say, and I like to thank Intel as well, because it's the openness of the mind, right? When you try to have 2 different components, 2 different IPs working together, there's a lot more knowledge sharing happening between us. And there is a lot of things that we have to go through some tension between the companies, but yes, we did it, and actually it's working, here. So if you look at here, basically on the left side, you can see a Lattice device running an X03 with an LTPI IP, and you can see on the right side, which is a green one, which is an Intel Max 10 device running this LTPI. Ideally, we had to use an interproject board here, because typically you want to run your SCM board with an HPM board, right, to do the pin mapping. But since HPM was not available today, so you had to do a interproject board here. And if you look at both of them, is using ASpeed as a BMC, running an open BMC. And the left side and right side, I know that window probably is difficult to see, but trust me, it's actually running I2C, GPIO, EWART, or all those typical LTPI channels. And it's actually, as I said, it is a working demo. That's, if somebody is interested, look at that. And it's a very significant demo for all perspective, right? It's a truly OCP-inspired demo that multiple companies working together and basically making this interface, one interface for all of us. So if I go to the next page, so obviously anytime you see this, there's a lot of challenges that we see, right? Because I just said that the spec, new developed specs, And what's happening, this is some of the challenges that we had to go through, which is SE coupling, clock architecture. Spec says something, we understand one way, Intel understood different way. That's always a common thing, right? And especially in the development phase, not everything is very well spelled out in the first generation of the spec. So what we're trying to tell here is that all these challenges we tackled. It's a significant achievement for both Intel and us. We tackled. It's working. So that means, if you have a Lincoln City board and if you have a City board, it should be workable together. Because of this particular effort that we did. But the outcome of this one is actually that what we are driving this LTPI 2.1 spec, right? Today, LTPI 2.1 spec has LTPI defined as it is, but all the findings that we're doing, Casper, myself, Lawrence, we're actually driving through those OCP to make it more interoperable, to make it more transparent to multiple vendors. It may not have to be Intel, right? It can be any other vendors who is doing LTPI. So again, demo is there, and I think that's my last slide. With that, I'd like to introduce Lawrence. He's my colleague at Intel. Lawrence, you want to please? Thank you.
Thank you, Munir.
Thank you.
Hi, I'm Lawrence Lowe. I'm the cloud system architect for the Lincoln City design. So I want to use this opportunity to introduce the cloud reference design. We put a lot of effort to make this board to meet the cloud customer requirement, right? So including the power bus bar and those some of for the front I/O, real I/O, and also we got inspired by DC-MHS spec, right? So we put we make the connector to be the DC-MHS compliance, the DC, there's SIO, the PASTI, we are compatible with those. The most of the effort we put here is to develop a DC-SCM module. It's a 2.0 and complying with the DC-MHS spec. And we collaborate with Lattice, right, to develop an alternative solution, identify many the interoperability problem and driving the spec change. So we really appreciate the effort and collaboration with the Lattice. So in this design, we kind of give a customer, a good reference design for next generation. We call Intel Granite Rapids AP design. So we want to accelerate the customer, designing with a different solution and for their cloud the requirement. So this is the board form factor. We have a boost over there. Also welcome to you can see it and touch it and ask any question if you have any. Actually, and we have a document already published at the Intel RDC. The document number is over there, so welcome to take a reference design from there. So you can start to kick off your project now. Next, I will going to introduce another topic for Raku.
Hi everybody, I'm from a startup called Axiado. I'll introduce what we have done in the Experience Center today. So just a brief introduction of our product, which is we refer to as TCU, Trusted Compute and Control Unit. It's essentially, think of it like a DC-SCM on a single chip, okay? So it has the root-of-trust, the BMC, the TPM, the LAN on motherboard, and some of the CPLD functions all integrated into one chip. That's essentially our chip. You see the chip on the figure there. We have multiple demos at OCP. This is completely an OCP-inspired boards that we have built. Horizontal form factor DC-SCM, vertical form factor. In fact, the vertical form factor design has been open source to OCP, including the spec, the design files, everything, and it has been ratified last week. So anybody can go build those boards going forward. So just to take on more challenging tasks with Tyan, what we did was, in addition to solving the DC-SCM interoperability with the Tyan server and our DC-SCM card, we've also taken on adding Caliptra onto the same platform, where we worked with AMD, Tyan, to figure out how to interoperate between two Caliptra entities and over I2C and using SPDM. That's the demo you will see in the Experience Center there. Essentially, the setup is described there where the TCU, you see and the next to it is an FPGA which has the Caliptra RTL, 1.0 RTL integrated, and that interoperates with AMD Genoa's implementation of it, and then they both communicating the SPDM or I2C. And Caliptra, as you guys may know, is only for root-of-trust for measurements. So during the platform boot, the Caliptra IP comes up, does the measurements, and passes it to the requester, and it stashes the measurements, and then the rest of the dice attestation process follows after that. So you come check us out, Experience Center, and also we have a booth which shows several of these demos there. Thank you.